Very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7, our ongoing chapter, heat. And today we are entering into the session number 3, not 2, 3. Session number 3. Means so far we completed 2 classes, 2 sessions in understanding the concept of heat and temperature. So we'll continue where we left in the last class. But before that, let us recall what we learned in the 2 earlier classes. So simple, we learn about what is heat, what is temperature, right, in details, how they are related, difference between the heat and temperature, then how to measure the temperature by using the thermometer, and then we discussed about the different scales of thermometer in the last class, right? Different scales of thermometer, right? Celsius, right? Fahrenheit, and Kelvin, and finally Romer. In last class we learned about these thermometers, and we have seen what are the lower fixed points and higher fixed points of all the thermometers, and how they are constructed and how they are calibrated with the numbers, and what is the relation between them. Relation between all the 3 scales of thermometer, that is C by 100 is equal to, right? C by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 373 is equal to R minus 0 by 80. So this is the relation among all the 4 scales of thermometer we have seen, and I told you some examples also. Convert. We can convert one scale of temperature into another scale also. Whenever the degree Celsius is given, we convert that into Fahrenheit, or we can convert that into Kelvin also. So any degrees, anything can be converted into any other thing by using the relation between the thermometers, right? So that till then we have seen, which clearly explains about the concept of heat and temperature. Now when we move some next stage, little more about the heat, because our main focus is on heat only. So what we want to know about temperature is completed. What is temperature? How to measure the temperature? What is the device used to measure the temperature? And what are the scales of the temperature? All things completed. Now there is extension of the heat. To study more about heat, what we'll do is transmission of heat. The first part is transmission of heat. And second one is change of state. Change of state doesn't mean that Telangana to Andhra, Andhra to Odisha, West Bengal. State is nothing but matter, state of matter. Changing from solid to liquid, liquid to gases, right? That. First we'll discuss about transmission. Then we'll go for the change of state, right? Transmission of heat. Word itself indicates transmission is how heat travels from one place to another place. Suppose you take one spoon, place it on boiling water for some time. So heat comes from the lower end of the spoon to your hand. You feel very hot and you can leave. This feel hotness means heat is transferring from bottom to top. So that is called transmission. You might have observed the food preparation becomes cool when kept for a long time. This is because the heat passes from food to the surroundings. The heat is transferred from food to the surroundings. So heat is always transmitted from hot substance to cold substance. The transmission of heat takes place in 3 following ways: conduction, convection, and radiation. Means heat transfers from one place to another place in three ways. One is conduction, one is convection, other one is radiation. The first one is in solids, second one is in gas and liquids, and third one is in vacuum. The way the heat is transfers in different states of matter is classified into conduction, convection, and radiation of heat. Right? So first we start with the conduction. The process by which heat is transferred from hotter body to colder end an object is known as conduction. In solids, generally the heat transmitted by process called conduction. So here there is no movement of particles. Particles never move. In solid, the heat transfer takes place in solids is conduction. Common, if you take one iron rod, heat one end, you place it on the burning candle. After some time, what happened? The heat will pass us through that and you come to your hand. You leave the hand. Means heat is transmitting. There is no movement of particles also in the iron rod. We cannot, because all the particles are tightly packed. There is a transfer of heat takes place from one particle to another internally and reaches the other end. Like when you are holding the hot vessel, sometimes you get heat. Means in every solid, heat transmits from one end to another end without actual movement of the particles is called conduction of heat, which takes place in solids. So some explanation is given. You can see here. How does conduction take place? The substances are made up of many small particles. These particles cannot leave their own places. That is, they vibrate in their own place. The vibrations increases when the particles receives the more heat energy and heat is transferred from one particle to another particle. So in any metal, any solids, particle cannot change their position. Only they can do is they can, after receiving the heat, they can move here and there and they pass the heat to the next particle. Like that, they'll get the transmission from one body to another body. So the method of transmission of heat takes place in solids without actual movement of particles is called conduction. Clear? That is one of the way of conduction of heat or mode of conduction of heat. So where it is applicable, you can see applications. Cooking vessels are made up of metals so that heat is conducted through them and passes on to the food being cooked. Why you are using the metals, vessels, utensils to make them heat and will cook the food. Copper is good conductor of heat. Right? So copper bottom vessels are used to save time and fuel. So copper bottom will get steel vessel with copper bottom. Because why they are using copper? We cannot use directly copper, it's a little costly. In olden days they used to have, but now we are using aluminum or steel, stainless steel. But there is a copper bottom. The copper bottom, because it's a good conductor of heat, it absorbs the heat very fast and make the food to cook very quickly and can save the fuel also. Second one, mercury is used in thermometer liquid because of it is a good conductor of heat. So mercury also comes under semi-solid, that is, it is also used in thermometer just because of the good heater, good conductor of heat. And then automobiles radiators tubes made up of copper as a good conductor of heat. Being a good conductor, it absorbs the heat from the hot water from engine and transmits it to the surroundings. For the same reason, air conditioners and refrigerators also uses copper tubes. So to overall, copper is a good conductor of electricity. So you can find the application of this copper in even not only in automobiles engine radiators, it also uses refrigerator as well as air conditioners. And this fourth one, heat is passed onto solder through tip of the soldering iron, which is made up of copper. You might have seen soldering rod used to join the wires we use. Any electrician or TV mechanic comes to your house, you can see. He'll keep plugging for that, and the edge of the rod will become heat, and use a copper wire to solder the two parts, join the two parts. Because again, that is also a copper, because it is a good conductor of heat. So in this way, the conduction method can be observed in our day-to-day life, day-to-day applications, either in the copper bottom vessel, or in the mercury in the thermometer, or in the automobiles, or refrigerator, or air conditioner, or even soldering rod also. So this is a very good and important way of transmission of heat. Right? Now we'll come to the second part, that is convection. Convection of heat. So this takes place generally in the liquids and gases. So example, before starting with the example, suppose you switch on the geyser in bathroom for hot water. After some time on it, initially the water will come cool only. But later, the bottom portion water is very cool when compared to the surface. So what happened here? The surface particles, after becoming heat, they become light and go down, and they push the cold water to upper. Like the total water circulates, all the molecules moves from top to bottom and bottom to top, makes the total water heat. Even same you can observe in the, when you take one small bowl of water, place in the gas stove. Switch on the gas to observe carefully. As the heat strikes the bottom portion of the vessel, first bottom particles, bottom water particles will become heat, and they bubbles, in the form of bubbles, they come to surface. And topmost cold water will go inside because of more weight. They also, after some time, they also become heat, and because of continuous movement of the particles, the total water will become hot. Right? So it is a way of transmission of heat by actual movement of the particles. This is possible only in liquids and gases, because solids particle cannot move, but liquids and gases particles can move. Such a method is called convection. So water and air are the pure conductors of heat. Let us see water transmission takes place in the liquids and gases. Take beaker and fill half with water. Add some crystals of potassium permanganate to give the color to the water and heat it. Observe that water in a beaker carefully. Streams of colored water move upwards from the bottom of the beaker and then moves downward. When the water at the bottom gets heated and expands, the density of water becomes less. Hence, water becomes lighter and goes up to the top. At the top, the cool water, which has more density, comes down. Thus, heat is transferred upward by means of currents. Place liquid on it. These currents are called conventional currents. This way of transfer of heat takes place in liquids and gases is called convection. Just I told her how the hot water from the bottom go down and cold water from the surface. Sorry, hot water will come up and cold water go down. And finally, the total process completes, makes all the particles to become heat. Such method of transmission of heat in both liquids and gases due to actual movement of particles is called convection. Right? Some examples are given here. You can see convection also have applications because we use the solid liquids. A medium necessary for convection. There should be a medium. Without medium, it cannot transfer. The convection method not possible in the vacuum or space. In a process of convection, particles of medium moves from one place to another place. So, due to actual movement of the particles only, the convection process takes place. Whereas conduction doesn't require movement of particles. They just pass the energy to next and next. Clear? And the last method, radiation. Last method of transmission of heat is radiation. It takes place generally sunlight. It doesn't require any medium. It can take place through even vacuum also. Why we feel warm when we come out in the sun? As there is no medium in the space, heat cannot be transferred by either conduction or convection because they both require medium. The mode of transfer of heat, absence of medium, is called radiation. So, the mode of transmission of heat in absence of medium, means in vacuum or in space. All hot bodies, whether solid, liquid or gas, radiate heat in all directions around itself. When thermal radiations falls on a substance, some of it gets reflected and some of it is absorbed. The temperature of substance increases when it absorbs the heat. Otherwise, the white. Pour equal amount of water in the two vessels. The water in the black vessel is warmer than the white vessel. Thus, black body absorbs the more heat than the white body. Right? These are simple observations because of the radiation. When you see applications, the base of the cooking vessels are cooled when mud or painted dull to absorb more heat. White colored clothes are comfortable in summer and black colored clothes are comfortable in winter because white good reflector and if it absorbs less amount of heat. Black is a good absorber and good radiator also. It absorbs the more amount of heat and keeps you warm during the winter. So this application also useful for our regular life also. Generally in black, hot summer, we wear white shirts. Whereas winter we wear black. So both comfortable because of the radiation of heat in different methods. So while transporting the light inflammable substances like petrol and gas in the tankers are coated with the color which is good reflector of heat. Otherwise, the heat will come outside. So they are not allow the heat to come outside when you are carrying the petrol or diesel. Correct? Radiator. So before going for the next part, let us have one video on the
Today, we will learn the different modes of heat transfer. So let's start. Let's first learn what is heat. Heat is defined as the transfer of energy between two systems, and this energy transfers by means of particles bouncing into each other. So, we can say it is the transfer of heat energy from one object to the other object by means of the kinetic energy of particles bouncing into each other. When you bring two objects of different temperatures together, heat energy transfers from the hotter to the cooler object until the temperature of both objects becomes the same. Heat always transfers from hot to cold. Now let's learn the distinction between heat and temperature. Heat refers to the transfer of energy between systems or bodies, whereas temperature is determined by the energy contained within a singular system or body. In other words, heat is energy, while temperature is a measure of that energy. Adding heat to any body increases its temperature, while removing heat from any body lowers its temperature. Now let's learn why heat always travels from the hotter object to the cooler object. We know everything around us is matter, and matter is made up of particles, and particles have more energy at higher temperatures. So particles of hotter objects collide with slower moving particles of adjacent materials with cooler temperatures, and in this way they transfer some of their energy to the slower moving particles, and the process continues until all the particles are moving at the same rate. This is the process of heat transfer from a hotter region to a colder region. Now let's learn the units of heat.
They are still there only. They are vibrating.
तो काफी डैमेज हो गई।
No problem, मैंने पॉलिसी बाजार को बुला लिया।
सर, कार का रिपेयर और क्लेम सेटलमेंट सब
They are not moving from their places. Still,
काफी महंगा
the heat is transferring from
काफी सेव किया।
one body
पॉलिसी
to
बाजार से।
another body.
पॉलिसी बाजार पे कार इंश्योरेंस कंपेयर करके 8,000 रुपए तक बचाओ।
The SI unit of heat is joule. Heat is frequently also measured in the calorie, which is defined as the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. Heat transfer occurs in three modes, which are known as the three modes of heat transfer: conduction, convection, and radiation. Now let's learn all three of them one by one. Conduction. Conduction takes place at a microscopic level. In conduction, heat transfer takes place due to a temperature difference in a body or between bodies in thermal contact without the mixing of their mass. Atoms or molecules at higher temperatures have high levels of energy. Through vibration, this energy is passed on to neighboring atoms and molecules. Or we can say vibrating atoms and molecules transfer a part of their energy to neighboring molecules and atoms. This kind of heat transfer can take place between two or more substances or throughout a substance. Now let's have a look at some examples of conducting heat through conduction. When a car is turned on, the engine becomes hot and the hood becomes warm because the heat is conducted from the engine to the hood. The cup, which is carrying hot coffee or hot tea, becomes hot, and this is due to conducting heat. If we hold an ice cube in our hand, it melts because the heat is being conducted from our hand to the ice cube. Hot food turns the plate hot. This is also conducting of heat. Placing a pan on the burner or stove makes the pan or the pot hot due to conducting of heat.
All these are examples where you can see the conduction method.
Now let's learn what is convection. Convection is the mode of heat transfer in which fluids are moved in order to transfer heat. Now let's understand with the help of an example. Boiling water is an example of heat transfer through convection. First of all, a hot surface or flames heat up the pot. Heat transfers from the bottom layer of the pot to the bottom layer of the water. The warmer water moves upwards and the cooler water moves downwards. And this cycle continues this way.
What becomes
heated water is constantly
then
replaced by
cool
cooler
water
water in a circular manner.
You can see the bubbles also in the bucket.
This way, a transfer of heat is known as convection.
That is a convection method.
So here is the actual movement of heated atoms and molecules. Whereas in conduction, the heat is transferred through vibration. Atoms or molecules do not leave their original position. Now let's have some examples of heating through convection. Radiator. The radiator puts warm air out at the top and draws in cooler air at the bottom. Steam coming from a hot cup of coffee is an example of heat transfer through convection, as the steam is transferring heat from the coffee to the surrounding air through convection. Melting of ice is also an example of heat transfer through convection, as heat transfers from the surrounding air to the ice through convection. Hot air balloons are also examples of heat transfer through convection, as a heater inside the balloon heats the air and so the air moves upwards. This causes the balloon to rise because the hot air gets trapped inside. And when the pilot wants to descend or to come downward, he releases some of the hot air, and cool air takes its place, which causes the balloon to come downwards.
See, going up, hot air is required.
This was about convection. Let's
repeat.
repeat. Convection is the mode of heat transfer in which atoms or molecules actually move to transfer the heat. And in the case of conduction, there is no movement of molecules from one place to the other. Molecules only vibrate to transfer energy to the next molecule. Now let's learn about the third mode of heat transfer, which is called radiation. In this mode of heating, heat is transferred in the form of radiant energy, or wave motion from one body to another body, and no medium is required for this mode of heating, or heat is transferred through a transparent medium. The property of radiation is different from convection and conduction, as both convection and conduction require some medium for the heat to travel from the hotter region to the colder region. In the case of radiation, random movements of atoms and molecules in heated substances result in emission of electromagnetic waves that carry heat. So the heat or warmth that you feel while sitting near any hot object is due to the radiation of heat from that hot object. For example, sitting near a fireplace, you feel warmth due to the radiation of heat from the fire. Heat is not only radiated from hot objects. Every object above 0 degrees Kelvin or negative 273 degrees Celsius is radiating heat all the time. Yes, every object. Let's have an example. This is a hot cup of coffee. Will it stay hot forever? No, it will achieve room temperature in some time. Why? Let's learn. All the objects that have a temperature above 0 degrees Kelvin radiate heat and also absorb heat all the time. When temperature of the object is higher than its surroundings, then it radiates more heat than the heat that it is absorbing. And as a result, its temperature keeps on decreasing until it becomes equal to the temperature of its surroundings. And then it radiates and absorbs
Anyway,
the
you
same
understand exactly what are the three modes of transmission of heat clearly, right? Then when you see the last part, expansion of water, change of state. So change of state is already you know very well in the lower classes. So when the body is heated, a solid is heated, it converts into liquid, liquid into gas. So converting solid into liquid is called melting, the melting point. Liquid into gas is called boiling point. Again, gas into liquid is called conduction. Sorry, conduction, and again liquid into solid also freezing point. So like that, whenever solid is heated, it not only will expand, solids are expands lengthwise, breadthwise, area wise, whereas only liquids and gas will expand only volume because they does not have any shape. But while this change of state, so heat is absorbed or heat is radiated. When you are observing the heat, solid will convert into liquid, liquid into gas. But again, the gas will convert into liquid and by solid by releasing of heat. So different methods are there which you already learned. One is condensation, one is freezing, melting, and evaporation. Melting, boiling, evaporation, condensation, freezing. All these are the different terminology used to convert the solid into liquid, liquid into gas, gas again into liquid, liquid into again liquid into gas. All these points are very important definitions. Okay. So, and along with that, that heat absorbed by any body depends on some factors. Some factors we'll discuss in the next class. The factors affecting the things, right? So today we learn more about the very important points of about the transmission of heat, how the heat transmits in solids, liquids, gases, and vacuum. Right? So that's all for today. Thank you, all of you. Have a wonderful day. Thank you.